Welcome back. Today we're doing a full architecture breakdown of the Model Context Protocol, MCP, and specifically the massive spec revision that's about to ship. If you've built anything with MCP servers, this episode matters to you because on July 28th, 2026, the way MCP works under the hood changes. Fundamentally, we're talking about the handshake being removed, sessions being removed, the entire stateful backbone of the protocol gone, replaced with something that scales completely differently. By the end of this video, you'll understand exactly how MCP is structured today, why that structure started to crack at scale, and how the new stateless core fixes it, plus the new extensions framework, the auth hardening, and what's getting deprecated. Grab a coffee, this is a deep one. Let's get into it. Let's start with why this matters right now. Mark your calendar, July 28th, 2026. That's when this spec version becomes final. The release candidate locked on May 21st, giving SDK maintainers a 10-week window to validate against real workloads. And this isn't a small patch. The MCP maintainers themselves call it the largest revision of the protocol since launch. 6 specification enhancement proposals, SEPs, landed together to pull this off. Now, here's the good news buried in all this change. Going forward, there's a formal 12-month minimum deprecation window before any feature can actually be removed. So this kind of breaking change, this is meant to be the last one of its size. Okay, so what exactly is changing? Let's back up and look at how MCP is built today before we get into what's new. So 3 roles. First, the host. That's the actual LLM application. Think Claude Code, an IDE, a chat client. Second, the client, a connector that lives inside the host, and it maintains a one-to-one relationship with a server. And third, the server. That's the thing exposing tools, data, and prompt templates back to the model. All of them talk using JSON RPC 2.0, a lightweight message format that's been around for years, nothing fancy there. Now, here's an interesting detail. A single host doesn't just talk to one server. It can spin up many client server pairs simultaneously, each one isolated from the others. That's the skeleton. MCP took a lot of inspiration from the language server protocol, same idea, just for tools and context instead of programming languages. Next, let's look at what servers actually hand back across that connection. Once a client and server are connected, the server can offer 3 kinds of features. Resources, that's context and data, the model can read like a file or a database record. Prompts, pre-built templated messages and workflows the user can trigger. And tools, actual functions the model can call to take action. All of this rides on plain JSON RPC calls. Here's a real example. A tools or call request for a search tool with a query argument. Simple, readable, nothing magic. Clients can offer things back to servers too. Sampling, routes, elicitation. We'll come back to a couple of those later because they're actually being deprecated in this new spec. But first, I want to show you how a call like this one actually got routed under the old architecture, because that's where the real story starts. Okay, here's how it worked before. A client opens a connection with an initialize handshake, protocol version, capabilities, client info, all exchanged upfront. The server responds with an MCP session ID, and that ID has to be attached to every single request after that. The problem, that session lives on one server instance. So if you're running 3 servers behind a load balancer, the client gets pinned, stuck to whichever instance issued that session. Server B, server C, completely unreachable for this client, even if they're sitting idle. And if you want horizontal scaling, now you need a shared session store, so any instance could theoretically look up state plus sticky routing at the load balancer, so requests keep landing on the right box. That's operational overhead nobody asked for. Let's talk about exactly where this broke down in production. 3 specific costs, and if you've operated MCP servers behind a load balancer, you've probably felt at least one of these. First, sticky routing. Your load balancer can't just round robin traffic anymore. It has to remember which box owns which session. Second, a shared session store. Now, every server instance needs a way to read the same session state, which usually means adding infrastructure, Redis, a database, something, just for protocol bookkeeping. Third, deep packet inspection. Gateways and rate limiters have to actually open up the message body to figure out what operation is even happening because the routing information isn't sitting in a clean header anywhere. None of this is what you signed up for when you deployed a tool server. This is exactly the pain the 2026 rewrite goes after. Let's look at the fix. Here's the rework. The initialize handshake, gone. The MCP-session-ID header, gone. Client info, protocol version, capabilities, all of that now travels inside underscore meta on every single request instead of being negotiated once upfront. So look at this call. It's completely self-contained. It's got an MCP-method header and MCP-name header right there in plain sight. So a load balancer can literally root on the header without opening the body. And because there's no session tied to one box, this request can land on server A, B, or C. Doesn't matter, plain round robin, no sticky routing, no shared session store. There's also a new server/discover method if a client wants to fetch server capabilities upfront, on demand. But, and this is the part people get wrong at first, stateless protocol does not mean stateless application. So how do you carry state across calls now? That's next. So if the protocol doesn't manage sessions anymore, how does a server remember anything across two calls? The answer is refreshingly simple. It's the same pattern HTTP API have used forever. The server mints an explicit handle. In this example, a basket ID, the model calls create underscore basket, gets back a basket underscore ID, and then just passes that same ID back as a normal argument on the next call. Add underscore item. No hidden session, no sticky routing needed to remember it. It's just data flowing through the conversation like anything else. And honestly, this turns out to be more powerful than the old hidden session state because now the model can reason about that handle, compose it across different tools, hand it off between steps. Nothing is hidden in transport metadata anymore. Okay? Protocol core sorted. Now let's talk about what's being added on top. Extensions. New capabilities in this spec don't just get bolted onto the core protocol anymore, they ship as extensions. Each one gets a reverse DNS ID, its own repository, its own maintainers, and it can version independently of the main spec. Two official extensions ship with this release. First, MCP Apps. Servers can now ship actual interactive HTML interfaces, and hosts render them inside a sandboxed iframe. Tools declare their UI templates ahead of time, so hosts can prefetch and security review before anything runs. Every action the UI takes still goes through the same JSON RPC audit path as a normal tool call, so you're not losing the consent model just because there's a UI now. Second, tasks. This existed experimentally before, but it's been redesigned for the stateless world. A tools/call can now return a task handle instead of an immediate result, and the client drives it forward with tasks/get, tasks/update, tasks/cancel. The server decides when something should run as a task. It's server directed. One thing that got removed, tasks/list. Turns out you can't scope that safely without sessions, so it's gone. Next, let's talk about auth because that got a serious hardening pass too. MCP's authorization spec just got 6 SEP worth of hardening, and the theme across all of them is align more closely with how OAuth and OpenID Connect actually get deployed in the real world. Quick highlights. Clients must now validate the ISS parameter on authorization responses per RFC 9207. That closes off a mix-up attack that's especially relevant given MCP's single client many server pattern. Clients declare their application type during dynamic client registration now, which fixes a really annoying bug class, a desktop or CLI client getting defaulted to web and then having its local host redirect URI rejected. Registered credentials get bound to the issuing authorization server and clients re-register if a resource migrates between auth servers. And the spec now documents how to request refresh tokens from OpenID Connect style servers, plus clarifies scope accumulation during step-up auth. None of this is flashy, but if you're running MCP servers in production, this is exactly the stuff that saves you from a security incident. Now, let's talk about what's getting phased out. Three core features get formally deprecated in this release: routes, sampling, and logging. Routes gets replaced by tool parameters, resource URI, or plain server configuration. Sampling gets replaced by direct integration with your LLM provider's API. And logging moves to standard error for standard input-output transports or open telemetry if you want real structured observability. Important nuance here. These are annotation-only deprecations. The methods still work today, and they're guaranteed to keep working for at least 12 months under the new feature lifecycle policy before anyone can even propose removing them. So don't panic and rip code out tomorrow, but do start planning the migration because the direction is clear. There's also a smaller but very real breaking change buried in here. The error code for a missing resource moves from a custom -32,002 to the standard JSON RPC -32,602. If your client matches on that literal code anywhere, go update it. Okay, let's zoom out and look at the release timeline as a whole. Let's put the whole rollout on one timeline. The release candidate locked on May 21st, 2026. That kicked off a 10-week validation window for SDK maintainers and client implementers to test against real workloads. Tier 1 SDKs are expected to ship support inside that window. Then, July 28th, 2026, final spec, July 28th, 2026, ships. And zooming out on the numbers, 6 SEPs came together just to deliver the stateless core. 2 official extensions launch alongside it: MCP Apps and Tasks. Another 6 SEPs hardened authorization. And going forward, every deprecated feature gets a minimum 12-month runway before it can be removed. That last number is really the point of this whole release. It's not just about this one breaking change, it's about making sure this is the last time MCP has to break this hard. All right, let's wrap this up. So, 3 pillars to remember from this whole architecture breakdown. 1, a stateless core, no handshake, no session, any server instance can handle any request. 2, extensions. So, new capabilities like MCP apps and tasks can now ship and evolve independently of the core spec. And 3, hardened authorization that actually matches how OAuth and OpenID Connect get deployed in production. If you're building or operating MCP servers, don't wait until July 28th. The release candidate is available right now, so go test your implementation against it. That's the full architecture explained. If this kind of deep dive is useful, let me know, and thanks for watching. I'll see you in the next one.